Think of a volcano, and the image that comes to mind is a mountain, miles high, with steam rising out of its crater. But the volcano here at Yellowstone's a little bit different. We're standing on it. Nearly all of Yellowstone's 2 million acres sit on top of an enormous underground supervolcano, 40 miles wide. Its crater is here, just below the surface, and down there is molten rock, the source of intense heat that powers Old Faithful. And the simmering volcano fuels the hot springs here as well, a cradle to some of the most primitive microbes on the planet. Bathed in a primordial soup, incubated by volcanic steam, the organisms flourish. This led some scientists to speculate that a setting with conditions like these here at Yellowstone could have been where life first started. And our next great discovery demonstrated how it might have happened. In 1953, a doctoral student named Stanley Miller conducted a series of experiments to reproduce in his lab the same conditions that had probably existed on primeval Earth. Water, but no oxygen in the air. An atmosphere teeming with a mix of gases. Sulfur and methane, hydrogen and ammonia. Miller started by filling an enclosed container with water. Then he added the mix of gases. To replicate the effect of the sun, he heated the mixture with a Bunsen burner. To simulate lightning bolts, he jolted the concoction with bursts of electricity. He waited several days before analyzing the liquid in the container. The results were astonishing. The liquid contained organic compounds, essential building blocks for creating proteins, which play a vital role in the biochemical spark that starts life. So what did Stanley Miller discover? While he didn't create life in the lab, he created the potential for life, and that's significant. It meant with the right raw materials and the right conditions, life could happen anywhere. However, there's no shortage of theories. Some scientists have even speculated that the life-building proteins that Stanley Miller created in his lab could have arrived aboard a comet or asteroid from deep space, seeding the Earth. Or perhaps the answer lies at the bottom of the ocean, with our next great discovery. The Pacific Ocean, 250 miles off the coast of the Galapagos Islands. In 1977, a deep-sea submarine descended over 8,000 feet. Its mission? To investigate hydrothermal activity on the ocean floor. Marine explorer Robert Ballard was aboard. He detected a dramatic change in the ocean's temperature.
You know, we were not expecting what we found. We were expecting to find water, and we had a camera inside the vehicle, but it was just taking pictures, so we didn't know what we had till we came back. And we brought it up to the surface, and we processed the film, and we knew the spot where the temperature spike was, and it was like going to Disneyland. Probably one of the biggest biological discoveries ever made on Earth was made that day.
Ballard and his team were the first to see it, face to face. Hydrothermal vents. Immense chimney-like structures, several stories high, spewing hot water geysers, black with minerals and nutrients. The temperature around these deep-sea vents was a scorching 760 degrees Fahrenheit. And then an astonishing sight. Life, thriving without sunlight, a biological community never seen before. An exotic garden of marine life, species without eyes, others resembling Triassic-era fossils, over 200 million years old.
What we totally were blown away by were these giant tube worms, some of them 8, 9, 10 feet tall. And when you cut them, they bled human-like blood. I mean, when the submarine landed, there was a squish, and red blood came up around all the portholes. And that's how eerie it was. And then to find these extremely unusual creatures living in this oasis. It had no relationship to the normal life of the deep sea. And yet here they were living in this toxic water. But yet these creatures were thriving on it. And then when we dissected, I remember we took one of these clams and we opened it up in the first place. Whew, as soon as we opened it up, it stunk.
It was full of hydrogen sulfide.
Horrible smell.
Rotten eggs.
Yeah. And we opened it up and then we looked and it didn't look, it looked like beef. It was red, bright red. And it didn't have an anatomy of a clam. It was like, what happened to the clam? Someone had taken over its body. And that something was a bacterium, a tiny bacterium that had figured out over eons of time how to duplicate photosynthesis in the dark chemically through a process we now call chemosynthesis. And that was the discovery, that there was another life system on Earth that did not go by the book that you and I read, that was not living off the energy of the sun, but was living off the energy of the Earth itself. And that really opens up the ballgame.
I'll say.
And these bacterium, we now think are the largest mass of living things on Earth.
That they're in the rocks
In
everywhere.
the whole
under-
mountain range.
Under the ocean.
If you added up all the people and all the living things on land and add up all the creatures in the ocean and the few things in the sky, and you got a number, so many tons, there's more tons of biomass. We used to just think, you know, the insects ruled
That's
the
right,
Earth.
yeah.
Wrong. These bacterium,
So where are these vents?
all over the Earth. They were, imagine a baseball with a seam on it. That seam begins beneath the polar ice caps, goes down through the Atlantic, into the Indian Ocean, across the Pacific. It runs around the Earth for 42,000 miles. It's the largest feature on Earth, the mid-ocean ridge, and it's underlain by literally tens of thousands of magma chambers.
Is that where life began? In the hot
that's-
springs?
Well, that's what people are now thinking. The biology books that we were reading have now been thrown away.
Yeah.
And they're
when I
writing
grew
new
up,
ones.
everything, you had to be on the surface.
That's
in the
right, and you
sunlight.
had this soup and the lightning bolt hit it and you formed all sorts of amino acids and things like that. But now what we think is that the hydrothermal vents may have been the site of life on Earth. It's also given us a new prospecting tool for searching for it elsewhere with our own solar system. We're now looking at a moon of Jupiter called Europa, which we think has an ocean. We think it has underwater volcanoes, and there should be life down there. The question is, how smart are their clams?
Did hydrothermal vents give birth to the first primitive microbes on Earth? Perhaps. But one thing is certain. Their discovery challenged long-held beliefs about the conditions necessary for creating life. And once life happened, there was no stopping it.